In this video, I'm going to outline the concept of random variables, and in particular I'm going to focus on discrete probability distributions to include how to compute their mean, variance, and standard deviation. Let's get started by defining a random variable. A random variable associates a numerical value with each outcome of an experiment. It is very important that you know and define exactly what your random variable is. For example, in these discrete situations, I have set a specific verbiage consistent with each experiment. For example, the random variable x represents the number of overtime hours worked in 1 week per employee, or the random variable x represents number of movies currently playing in the US. Now let's look at a specific situation and define it in a table. I perform an experiment and flip a coin twice. I set my random variable x to be the number of tails when the experiment is performed. I can also set a second random variable, represented here by y, to be the number of heads minus the number of tails when the experiment is conducted. These are two of many random variables possible for this experiment. Extending the current example and working with the random variable of x, the number of tails to appear when 2 flips of a coin are the experiment, I can build a probability distribution table that gives the possible values of the random variable and the probabilities of each occurring. Every probability distribution must satisfy 2 requirements: that the sum of all the probabilities equal to 1, and the probability for every individual value of x falls between 0 and 1 inclusive. If these 2 requirements are not satisfied, then the probability distribution does not exist as written. Now let's look at an existing probability distribution and find its mean, variance, and standard deviation. We find the mean by calculating the summation of the product of each x and its corresponding probability. The first table I have created at the right of the original problem shows my calculations as I multiplied 0 times 0.10, 1 times 0.25, and so on. I added each product to get the final sum and determined my mean in this problem to be 1.75. The next table over that I created helps me calculate the variance, which is the summation of x minus mu squared multiplied with the probability. I add my values at the end and calculate my variance to be 0.8875. Standard deviation is found by taking the square root of the variance, which is 0.9421. In this additional example, I find the product of the values of the random variable and corresponding probabilities and then take the sum. My mean in this discrete probability distribution is 5.3. And finally, I use the value of the mean, the values of the random variable x, and the probability of each value to find the variance of the example. I determine the variance to be 3.6 and the standard deviation to be 1.913. Appreciate you watching. If you would, please leave a like, subscribe, and comment to add to the discussion. Thanks in advance.